Hello, this is a review of the Hobbymate 20 amp BLHeli-S ESC. This ESC supports one-shot 125, one-shot 42, multi-shot, as well as D-shot 150, D-shot 300, and D-shot 600. You can see it is very small. It is approximately 24 millimeters long by about 12 millimeters wide by about 5.5 millimeters thick. It weighs about 3.8 grams without the wires and about 5 grams with the wires. As I mentioned, it handles up to 20 amps continuously and up to 30 amps for 10-second bursts. The ESCs also come with a detailed user manual. You can see that it lists the features here, the specifications we reviewed. It shows how to wire it up. It shows the startup process. It shows how to calibrate the throttle range. It has all the programming items, detailed instructions. I'll be using BLHeli Suite to configure these through the Betaflight pass-through, but you can also do it via transmitter stick commands. So I'm going to be using these new ESCs in a Hobbymate QAV 210 build. So let's take a closer look at some of the other parts. So we have the QAV 210 frame. The bottom plate is 3 millimeters thick. The top plates are 1.5 millimeters thick. The kit comes with both a Dean's and an XT60 power lead. Comes with a prop wrench, comes with motor guards, comes with extra standoffs, comes with a battery strap. I'm also going to be using Hobbymate 2205 brushless motors. These are 2300 kV. I've had a lot of good success with these in the past. Also included in the kit are some Jam Fan 40-45 bullnose props. For the power distribution board, I'm going to be using the Hobbymate 5-in-1 PDB. So this has 5 different functions on it. It acts as obviously as a PDB, has 20 amp compatibility for each one of the outputs. It has BEC, both 5 volts and 12 volts. It has LED controller, has a lost plane function. It has a beeper here on here so that you can activate it through the aux channel, which is connected right here through an aux channel, and activate the beeper. And also has a low voltage alarm that you can see. You can use this button to select which one of the voltages that you want it to alarm on. So that comes with standoffs and the aux power lead. For the receiver, I'm going to use a Hobbymate DSM2 DSMX receiver. You can see it has a bind button on it, so you don't need to hook this up to a master receiver in order to get to bind. You can bind it directly with just this, just using the bind button. For the flight controller, I'm going to use my SP Racing F3. I've already got the pigtail hooked up to it for the satellite receiver and a beeper wired up to it. For the transmitter, I'm going to use a standard 40 channel 200 milliwatt transmitter with a cloverleaf antenna. And for the camera, I'm going to use a Runcam Swift 2. So now I'm going to assemble everything and I'll be right back. So I just got done with the build, so let's take a closer look. I trimmed back the motor leads quite a bit and soldered those onto the ESC pads. The ESC pads took the solder really nicely. You'll notice here there's an extra piece of heat shrink on here. When you get the ESCs, they'll give you this extra piece, and that way you can slide it on and cover up your motor wires. So the ESCs are soldered onto the power distribution board along with the battery lead. On the power distribution board, you'll notice there's a little button right here. This little button is to select the voltage that the buzzer will alarm at. So I think you have 3.4 volts, 3.5 volts, or 3.6 volts as an option here. You got a little LED that lights up and tells you which one you have selected. You remember we had this auxiliary input here. This is connected up to my flight controller. This supplies 5 volts to my flight controller, and also on the motor output on the flight controller, you can configure it so that it alarms, or it makes this beeper beep here, and you can use it for the lost model function. Okay, moving on, we have the camera here and the video TX, which is being supplied by 12 volts off the power distribution board. And also the DSM-2 and DSM-X satellite receiver. This is wired up to my flight controller, and of course remember these always get 3.3 volts instead of 5 volts. So that's pretty much it. I think it turned out really nice. So next step is to go over to the computer and hook it up to Betaflight. One more thing I want to show you. These ESCs are incredibly small. So this is a 130 frame, and you can see here that there's enough room to install these ESCs even on a frame this small. So from 250 down to 130, I would say that these would probably, you have room here to fit even this down on a 100mm frame. So these are really, really small ESCs. We did the measurements before, but they are incredibly small. Okay, onto the computer.
Okay, here we are in Betaflight. I've got my quadcopter hooked up to the USB port. It's on serial COM 3. I'll click connect. We see that it's connected and reacting. First of all, go down to CLI, type in version, and you'll see that my firmware version is the latest. It's 3.1.6. This is the latest for my flight controller, which is the SP Racing F3. So back up to setup. One of the things I'll do is I'll enable expert mode. That way I can see all the various tabs. So first one is ports. I have my Hobbymate satellite receiver hooked up to my flight controller on UART3, so I have that serial RX enabled on that serial port. On configuration, quad X of course. So for the ESC protocols under the motor features, these are all our options. So we have pulse width modulated, one shot 125, 42, multi-shot, obviously brush we're not interested in. We have D-shot 150, 300, and 600. So these ESCs are compatible with all of these, obviously with the exception of brushed, they're all compatible. So pulse width modulated, one shot 125, 42, and multi-shot are all analog protocols. In order of increasing analog speed, so multi-shot is the fastest analog speed, and then you have D-shot 150, 300, and 600 are all digital protocols. And if you have a F3 or F4 flight controller, likely that you'll be compatible with the newest digital protocols. I'm going to be configuring mine for this D-shot 600. It's available here. It shows it's available, so I'm going to select it. And I'm not going to go into all the nitty-gritty details on why D-shot is preferred. The digital protocols are preferred over the analog protocols, but if those are available to you, I highly encourage you using those. It allows for more precise reactions from the ESCs to the motors. So Oscar Lang has done a fantastic job, and I'll include the link to this in the video description. Done a fantastic job of describing all the different protocols. There's information here on the analog protocols. It talks about the differences in digital, the speeds at which these protocols talk back and forth to the motors, and goes into all the details. But D-Shot is the latest. These ESCs are compatible with it, and they do not require any kind of modification in order to get them to work. On some older types of ESCs, you had to remove some capacitors to get them to work. That's not the case with these Hobbymate 20 amp ESCs. They work straight out of the box and they're compatible with D-Shot. Okay, so I am selecting D-Shot 600. I like to have the motor stop enabled when I have it armed. Do not want the motor spinning. Down here I have my DSM2 satellite receiver mode selected. My particular transmitter is Toxon Spectrum 124. Other option is Spectrum 2048. If you have the wrong one selected here, if you happen to be using DSM, you'll see that on the receiver tab that the channels aren't reading out correctly. You need to switch those and save and reboot, and it usually fixes the problem. I have VBAT monitoring. I also have, this is my PID loop frequencies, and that's about it on this screen. So for failsafe, I do like it to drop. I do not want to continue to fly, so that's really the only setting there. These are PIDs for my particular quadcopter. These work out pretty good. On the receiver tab, I'll go ahead and plug in. I turn on my transmitter, plug in a battery. Props are off, obviously. Okay, so here we are. You can see that as I move my gimbals, that I see a reaction here on the screen. You always want to change your servo throws so that you get a full around 1,000, midpoint around 1,500, and full around 2,000 on each one of your your pitch or your roll, pitch, yaw, and throttle. You can see I have that here. I've got this is my aux1 switch here, and my three-way switch on aux2, and then ultimately my aux3 switch. See all those are working correctly. So I'm moving on to modes. So on my aux1, I have it arming the quadcopter. And so on my aux2, I have it is my flight mode. And so the first position is angle, second position is horizon, and third position is not either angle or horizon. So this is acro mode, and I have air mode turned on for this mode. That's the way I like to. That's typically the mode that I fly in is in acro with air mode on. So nothing in adjustments, nothing in servos. So we're going down to motors here. So obviously props are off still. So you turn on this so that you understand. So we're going to spin our motors, and what we're going to do here is learn which one of our motors, if they're spinning the correct direction. So as you saw when I wired up the motors to the ESCs, I didn't try to figure out which way the motor might turn, because I know that I can set that up inside BLHeli Suite. But here I need to figure out which ones are turning correct directions and which ones aren't, so I know which ones reverse inside BLHeli Suite. So we'll start the motors up, and so you just have to turn them on just a little bit. And so you check the direction on each motor. So motor 1 should be spinning this way, and in fact mine's turning the wrong way. So I'm going to have to reverse motor 1, feeling motor 2, okay, it's spinning the right direction. Motor 3, spinning the right direction. Motor 4, spinning the wrong direction. So I'm going to have to reverse motors 1 and 4 inside BLHeli Suite. So that's one of the nice things about these ESCs, is that you can configure and change that inside BLHeli Suite really easily. All right, so we'll turn that off. And that is it. If you're using one of the digital protocols, it's not necessary to do the throttle calibration. But if you're using one of the analogs ones, it is. So in order to show that, I'll go ahead and select multi-shot, hit save and reboot, and then we'll go over to the motors tab. And so again, what we're going to do is we're going to span the throttle. And so I'll click that I understand, and the props are off. So what you do here is you move, without the battery connected, you move this all slaughter all the way to the top. and then you plug in the battery, and you'll hear a series of tones. And when it gets done making the tones, you bring it all the way down. And when the tones are finished, you finished your throttle calibration. And that's all there is to it. And now back over to the configuration tab. And I'm going to go ahead and leave this in multi-shot right now, because when we go over to BLHeli Suite to reverse that ESCs number 1 and 4, then you cannot enter BLHeli Suite with D-Shot activated. It needs to be one of the analog protocols. But I'll come back here after BLHeli Suite and switch this back to D-Shot 600 for me. But for now, I'll leave it on multi-shot. So now we'll go over to BLHeli Suite and configure those 2 ESCs and reverse those. So first thing we need to do is download BLHeli Suite. So if you put this address into Google, and you can go to this website, and there's a link here to download BLHeli Suite, and I'll include this link in the video description. And here you download the zip file, and then you'll extract the zip and you'll run the executable. The first thing you want to do is make sure you have the right interface selected. You want to have this SI Labs BLHeli bootloader clean fight. Okay, so make sure that's selected, and then you can make sure that your COM port is the right COM port. Hit connect. You can check it by hitting this check button here. So it's communicating with all 4 ESCs. So from here you can see that this has firmware CH20 Rev 16.6. And so the question would be is this the latest firmware? So to check if it's the latest firmware, you just click this flash firmware button down here, drop down box. Okay, 16.6 is the latest, so there's no need to update the firmware. But if you did want to update the firmware, then you would do it right here. Okay, so now back, we can see that we have ESC1 is the one that we're looking at right now. So it was 1 and 4 that I needed to reverse. So all I have to do is click that to reversed, then write the setup, and it says, okay, it wrote to ESC1 and didn't write anything into any other ones. All right. So now I'll go over to ESC4, and you can see that it's listed up here, and I'm going to change it to reversed, and I'm going to write it setup. Okay. Now, once we have those 2 written, that's all I need to do here. So I'll just check it by going to the ESC overview. And I can see here, have them all selected. I can see here that ESC 1 and 4 are both reversed. So that's all I got to do. So I'm done with BLHeli Suite. I'll hit disconnect. Close this. Go back over to Betaflight. Connect up to Betaflight. Under my configuration, I'll choose my D-Shot 600, and I'll save and reboot. And then I can come over here to the Motors tab and just confirm that those 2 motors 1 and 4 change direction. So I can spin that up. Now 1 is spinning the correct direction, and 4 is spinning the correct direction. And of course, I didn't change either 2 or 3. Oh, all set to go. Okay, so now it's time to take it out for a test flight.
Alright, now let's try out these new Hobbymate 20 amp ESCs. Now I'm running D-Shot, and I've of course got this on the QAV 210 frame. Kind of feel the throttle response here. Very responsive. Try a little punch out. Oh yeah, nothing wrong with that. It feels so much more locked in than running this D-Shot 600. Very responsive. It does what the sticks do. I'm seeing a big difference in these and standard ESCs. All right, let's see what the ESCs and motors feel like. All right, the ESCs have no temperature at all, and neither do the motors. So they're passing the temperature test. These things are just ultra responsive. All right, one more temperature check and we'll again, nothing at all. Feels great. All right, Hobbymate. You did a good job with these ESCs. Using some of the advanced features of BLHeli-S with the D-Shot digital. It really makes the quad perform nicely, very dialed in. You did a good job with these.